All right, today's lesson on our unit Matter and Chemical Change is on topic 7, which is chemical reactions. So just a quick reminder of what a chemical reaction is, or how do we know a chemical reaction has taken place. So a chemical reaction, that's a process in which a substance is changed into one or more new substances. And those new substances will have new properties of their own that are different from the reactants. So basically, when two or more substances combine to form new substances, we know it's a chemical reaction. So the reactants are the substances that go into a chemical reaction, and then the products are the substances that are produced by a chemical reaction. All right, and like I said, the properties of the products are going to be different from those of the reactants. So here, just an example of chemical reactions taking place in the body. I won't go over all of them, but for example, in our mouth, in our saliva, we have enzymes in our saliva, and those enzymes start to digest the food that we eat, especially the starches, such as breads and other starchy foods with carbohydrates. Another example, the pancreas. The pancreas produces sodium bicarbonate, and that's important to neutralize any excessive acids in our stomach. So that would be another chemical reaction that's taking place inside the body. Okay, and there's some more listed here as well, and this is also in the textbook. Looking at some more examples of chemical reactions, here we have a potato, and then we have a solution of iodine. So if you put the solution on a raw potato, the iodine will react with the starch and it'll produce this blue-black color. And that's what's happening here. So a color change can indicate a chemical reaction. Here we see a precipitate. So recall that a precipitate is a solid being formed. All right, so here in this case, we have a precipitate is a suspension of small solid particles in a liquid, and sometimes a precipitate can be produced or a gas can be produced, okay, or dissolved in a chemical reaction. So that's another indicator. Heat and light can be absorbed or produced during a chemical reaction. So here, charcoal briquettes are burned, and heat and light is being produced. Here we have some moldy food. So when food spoils, the odor may change. So odor changes can also indicate a chemical reaction has taken place. All right, and we did go over these a little bit before when we had started the unit, but just a bit of review there. So now we're going to look at chemical equations. So in this example, we're looking at magnesium and oxygen. So magnesium is used to create bright light in fireworks and in flash bulbs. The magnesium oxide that is formed is soft, gray, and crumbles into dust. So the word equation here, written in words, is magnesium plus oxygen produces magnesium oxide. So we have an arrow in chemical reactions. On the left side of the arrow are the reactants. All right, so here are the reactants, and then on the right side of the arrow are the products. All right, so magnesium and oxygen are the two reactants, and then we have the product here, magnesium oxide. So secondly, we can write this as a chemical equation. So here we have 2Mg solid plus O2 gas produces 2MgO plus light. One thing to note here is when we are writing chemical reactions, the diatomic molecules we had talked about, they will apply here in reactions. So oxygen here is diatomic, so it is written as O2. And then we also have the subscripts showing the state of matter. So S for solid, G for gas, L for liquid, and then AQ, which stood for aqueous. All right, so this was the example we just saw. Magnesium and oxygen produce magnesium oxide. It's the same one we were just looking at. The numbers we see here as coefficients, those are used to balance an equation, but we won't be looking at that in this grade level. That's more for when you get into grade 10. All right, so let's take a look at an example here. We have C plus O2 plus carbon dioxide. All right, so the first example we have here, C. C is carbon. So we would say carbon and oxygen produce carbon dioxide. All right, so let's take a look at our second example here. We have zinc, we have hydrogen chloride, and we have two products being formed. All right, so for our second example, we have zinc plus hydrogen chloride produces zinc chloride and hydrogen. All right, our last example here, we have CH4. Does anybody remember what CH4 is? All right, and our last one here, we have CH4. So CH4, it is methane. But if you don't remember the name methane, you could have called it carbon tetrahydride as well. So methane plus oxygen produces carbon dioxide and water. And then if you didn't name it water, you could have named it dihydrogen monoxide. Okay, so here just a reminder of these subscripts here. S is for solid, L is liquid, G is gas, and AQ is aqueous in a water solution. All right, so for our first example here, we have solid mercury oxide produces liquid mercury and oxygen gas. So now we're going to try writing out these two examples here using the name as well as the state of matter. So let's do the first one. We have zinc, solid zinc, and HCl aqueous here. All right, so just a reminder here that AQ stands for aqueous, which means it is dissolved or in a water solution. So here we have solid zinc and aqueous hydrogen chloride. Produces, so we have aqueous zinc chloride, aqueous zinc chloride, and we have H2G, so that's hydrogen gas. All right, so reading this out loud, the whole reaction. So we have solid zinc and aqueous hydrogen chloride produces aqueous zinc chloride and hydrogen gas. So we've included the name of the chemicals or the chemical formulas, and we've also included the states of matter. All right, so for our third one, the first compound here is methane. So methane gas, you could have called it carbon tetrahydride, that would be fine as well. All right, so methane gas and oxygen gas produces carbon dioxide gas and water vapor. All right, so next is breaking chemical bonds. So chemical bonds are forces that cause a group of atoms to behave as a unit, and energy is stored in those chemical bonds. So to break bonds, energy has to be added. When bonds form, energy is released. So energy is either produced or absorbed during a chemical reaction. So we talked about exothermic and endothermic a little bit when we were doing that Gizmos lab. So an exothermic reaction, this is a chemical reaction that gives off heat. So for example, when the body metabolizes food during explosions. Here in this example, we have methane. The methane in natural gas is burned in a furnace. Energy in the form of heat is created. So this is a chemical equation here, and it is also a balanced chemical equation. So we have methane gas plus oxygen gas producing carbon dioxide gas, water vapor, and then energy as heat is being released. All right, here is another example of an exothermic reaction. So here we have hydrogen and oxygen reacting together with a little bit of energy, and it's producing water as well as a lot of energy. So it takes only a small amount of energy to start the reaction between hydrogen and oxygen to form the water, but then energy is released by the reaction, and that energy is much greater than we saw in the reactant side. So therefore, this reaction would also be considered exothermic. All right, this is just from the textbook. Nitroglycerine is used in explosives, but it is also used as medicine for heart disease. So tiny amounts of nitroglycerin can be taken in pill form, and they will dilate or open up constricted blood vessels. And so here, when we look at an explosion happening, it's an exothermic reaction. So the reaction of nitroglycerin with air will release a lot of energy. All right. And lastly are the endothermic reactions. So these are chemical reactions that will absorb energy. So for example, baking and cooking, those would be endothermic reactions, as well as a chemical cold pack. For first aid, it will absorb energy and become cooler. All right, so just a couple videos to show here.